Hello, welcome everyone. Myself Gagan. I am pursuing MCA in University of Mysore. In this video, I will be presenting on the topic handwritten recognition using neural network. These are the contents we look upon: introduction, objectives, offline recognition, OCR techniques, online recognition, character extraction algorithm, artificial neural network, use case diagram, architecture of the system, some aspects of handwriting recognition, and finally the conclusion. Let's start with an introduction. Ability of the computer to receive and interpret understandable and written inputs. Inputs include paper document and written photograph or from input device. Input may be offline from piece of paper offline handwriting recognition or online from movement of pens online handwriting recognition. A complete handwriting recognition system also handles formatting, performs correct segmentation into characters and find the most possible words. A segment of handwriting is a piece of the pen tip trajectory between two defined segmentation points. Objectives. To provide an easy user interface to input the object image, users should be able to upload the image. System should be able to pre-process the given input to suppress the background. System should detect text regions present in the image. System should retrieve text present in the image and display them to the user. Offline recognition. Optical character recognition. Mechanical or electronic conversion of images typed, handwritten or printed text into machine-encoded text. Scanner also scans the text document, but OCR is different as it scans each letters and characters in the document and saves it in the next document, whereas scanner scans the document and save it as image and it is not editable. Now let's look upon OCR techniques. First one, pre-processing. In that, DSkew makes lines of text perfectly horizontal or vertical. Despeckle removes noises from image and makes smooth edges. Binarization converts any image to grayscale and separates text from background. Layout analysis identifies columns, paragraphs, captions. Line and word detection, script recognition, normalize aspect ratio and scale. Second one is character recognition. It uses two basic character recognition algorithms. First one is matrix matching or pattern matching. It compares an image to store glyph on a pixel by pixel basis. Glyph means elemental symbol within agreed set of symbols. It works only if input glyph are separated correctly from rest of image and it matches the stored symbol in similar font in same scale. And next one is feature extraction. It decomposes the glyph into features like lines, closed loops, line directions, and line intersections. These features are compared with an abstract vector-like representation of a character. K-nearest algorithms are used to compare image feature with stored glyph features and nearest match is choose. Feature detection in computer vision. Computing abstract image information and making local decision at every image point whether there is an image feature of a given type at the point or not. Software like Cuneiform and Tesseract uses a two-pass approach to character recognition known as adaptive recognition. Adaptive recognition uses the letter shape recognition with high confidence at first pass to recognize better the remaining letters on the second pass. It is useful for unusual fonts and low quality scans. Third one is post-processing. OCR accuracy can be increased if the output is compared with the letters or words that makes meaningful words or sentence respectively but might not be useful for proper nouns. Example, I ate rice. Here, T is replaced by the dollar symbol, can be traced to I ate rice, but Ram ate. Here, dollar symbol is replaced by R. Ate rice cannot be traced to Ram ate rice as it could be Palm ate rice. Co-occurrences frequencies can be used by nothing certain words seen together. For example, Washington DC is seen more often than Washington DOC. English grammar can be used to determine whether word is noun or verb. And its applications are automatic number plate recognition, extracting business card information into a contact list, make electronic images of printed documents searchable, assistive technology for blind and visually impaired users, language translation for example of road signs. Next, going to the online recognition. Online in the sense that inputs are written on the screen instead of printed documents or written paper sheets. Sensor picks up the pen tip movements as well as pen up or pen down switching. This kind of data is known as digital ink and can be regarded as the digital representation of handwriting. The sensor signal is converted into letter codes for comparison. It uses mainly three processes. First one is pre-processing. They discard irrelevant information in input data, speed and accuracy considered. Binarization, normalization, smoothing, denoising done in online character recognition. Second one is feature extraction. Out of two or more dimensional vector field received from pre-processing algorithms, higher dimensional data is extracted. Includes pen pressure, velocity, or the changes of writing direction. Third one is classification. Various models are used to map the extracted features to different classes, thus identifying character or words the feature represent. And its applications are online conversion and return to text, signature approval, Google Translate application. Next is character extraction algorithm. You can see the image, that is original image and normalized image. The original image is normalized by using character extraction algorithm. First step, create a traverse list of pixels which have been already traversed. This list is initially empty. And next, scan row pixel by pixel. And next, whenever we get a black pixel, check whether the pixel is already in the traverse list. If it is, simply ignore and move on. Else, apply edge detection algorithm. And next, add the list of pixels returned by edge detection algorithm to traverse list. And next, continue the steps from 2 to 5 for all rows. This is the edge detection algorithm. The edge detection algorithm has a list called traverse list. It is the list of pixels already traversed by the algorithm. Edge detection x, y traverse list. First, add the current pixel to traverse list. The current position of pixel is x, y. Next, new traverse list is equal to traverse list plus current position x, y. If pixel at x minus 1, y minus 1, then check if it is not in traverse list. Edge detection x minus 1, y minus 1 new traverse list and end if pixel at x minus 1, y, then check if it is not in traverse list. Then edge detection x minus 1, y plus 1, new traverse list. And if pixel at x, y plus 1, then check if it is not in traverse list. Edge detection x, y plus 1, new traverse list. End if, and finally return. Next, moving on to artificial neural network. Artificial neural network refers to information processing paradigm or computing systems that are inspired by biological neural networks that constitute the human brain. The systems are not identical to the biological neural systems, but they are designed to process information the same way the human brain and animal brain process information. The networks are composed of many interconnected neurons working in unison to achieve specific goals, just like the human brain. ANN learns from example. Hence, an ANN can be configured for an application such as data classification or character recognition through the learning process. The learning process involves adjusting the system to a connection. The artificial neural network comprises a network of multiple simple processors, each with a small amount of local memory. The processors are linked together by unidirectional communication channels and operates only on local data and input they get through their links. Next, you can see the diagram of neural network. It consists of three layers: input layer, hidden layer, and output layer. Once the network is trained, the match pattern is obtained to generate the associated character. And next you can see some example, that is sample input and output. Output will be a beautiful version of the uploaded image and it will be saved in the doc or in text file. This is the use case diagram. A user can upload image and cancel it, and system is initialize, preprocess, segmentation, recognize and generate output. Preprocess involves in convert image into grayscale or grayscale to binary format and normalization. This is the architecture of the system. Input image and it next preprocess the image, and next it's segmentation and clipping, and next it feature extraction, and next is move on to the training and recognition, and finally generate the output. Here is some aspects of handwriting recognition. You can see the three image of health, how the different stages of handwriting segmentation. And next is segmentation problem. Can't read word until it is segmented or can't segment word until it is read. You can observe the image that recognize that is M or NR. And next is different handwriting styles. And next is the use of dictionary to correct for errors in reading. For example, you can see Smith. Outlines of word are traced and smooth. You can see the image how the word is traced and smooth. Segmentation. The main goal is to robustly cut letters into segments, match multiple segments to detect letters, easier than matching all letter. You can observe the image how letter is segmented. Finally, the conclusion. The feature extraction methods have performed well in the classification when fed to the neural network, and preprocessing of image using edge detection and normalization are the ideal choice for degraded noisy images. The method of training neural network with extracted features from sample images of each character has detection accuracy to a greater extent. The proposed methodology has produced good results for images containing handwritten text written in different styles, different size and alignment with varying background. The method is advantageous as it uses 9 features to train the neural network using character geometry and 12 features using gradient technique. These are the references I used for this presentation. Thank you everyone for spending the valuable time on my presentation. Hope you liked it.